Okay, for number 13, I want to recommend it's nice to know patterns. And looking at it, this does look like a pattern problem. And I want to point out the pattern that you should probably know about is this over here, the factorization of a cubed plus b cubed plus c cubed. These are uppercase letters, minus 3abc equals a plus b plus c times yada, yada, yada. All right? So what I'm going to claim over here is looking at it, the first thing I would do is I would just like to write in that form, and that's going to be 0 equals, right? So I'm going to be taking this from both sides, and you get this over here, right? I want to point out my understanding of the problem at this point is that this is the A, this is the B, and this is the big C, all right? What's this over here? It's the A, the B, and the big C, all right? So basically what I do is look at the formula. It's over here. So I write down A plus B plus C. And that would be, looking at it, I'm adding these three together. That's 3x plus A plus B plus C. Not bad. By the way, this equals 0. All right, then I got trouble over here. I'll tell you what the trouble is. I've got to multiply this out. All right, so I'm sorry. I don't have to. I'm sorry. I misspoke. I don't have to multiply that. I got to multiply this out. Sorry about that. So what am I doing over there? And I'll write down what I'm going to do, but I want you to do it. It's x plus a squared minus x plus a, x plus b. It's tough though. Plus b squared. That's x plus b, lowercase b squared, minus, I'm just doing these one at a time, a times c. Whoops, made a mistake. Did this. B times C. It's nasty work though, isn't it? And then what do you get? I just did the AC, BC, C squared. What do you get over there? Well, X plus C, quantity squared. So I'm going to say if you did that, you'd get this over here. Is it work to get there? It sure is, all right? So what I want to do now is go the next step, and we're just kind of looking at the key. All right, so I think I'm satisfied that if I knew that pattern, I could get this over here, all right? Now, someone says, well, if you get there, what are you going to do now? I'm going to use zero product rule. And remember, it has to do with the x. We're trying to solve for x. There's only one factor here that has an x in it, all right? So what would you write down? You'd write down 3x equals minus a, minus b, minus c. Divide through by 3, you would get minus a, minus b, minus c over 3. Most people would factor a minus 1 out from that and say minus, that would be a plus b plus c over 3. And that's what's written over here, all right? So the other thing is it's, getting this thing over here really doesn't matter what the x is over there. If that's 0, that would be true for all x, by the way. And that's written down for you. I also want to point out, I use Sage for it again, all right? So you notice in this problem set, I'm starting to write down some Sage code for the actual problems. And the reason for that, I find these problems to be quite tedious to do by hand. But it's amazing a computer algebra system could take this and chew it out in no time at all. So I basically type it in, and I put some things down over here. Let's see what I put down over here. Let's see. I say T2. I'm assigning T2 to be x plus b cubed. Yep, I see that. And T3 is x plus 3 cubed. I see that. T4, I put that down. You know what? I don't see T1 there, so there's a mistake over here. T1, I'm not sure why that's not there, by the way, but T1 should be assigned x plus a cubed. That's my mistake, and I need to correct the notes. You're not going to see that. I'm not sure why I didn't type that in there. But anyway, I got the terms and the sides. Looks like pretty good to me. And then I said solve. And when I solved it, let me point out what it gives me back. It gives me this over here. Whoops, sorry about that. Let me go backwards a little bit. It gives me this over here. Am I getting the same answer? I am getting the same answer, which is minus 1/3 of an A, minus 1/3 of a B, minus 1/3 of a C. Okay? Now, again, I want to go over to seeing if A equals B equals C equals 0, it's an identity that's true for all x. All right? It perhaps a little bit more difficult to understand that, but again, I did write this over here. All right? All right, I think we're done, and I think we got the answers over here. I think they did something a little bit spiffy over here, which I'm not going to go into. And yeah, I don't think I want to do that. But anyway, that's a much more difficult thing. Anyway, we'll stop there. So if you want to read this, you can. But I got to be honest, it's a little bit more difficult to deal with. All right? Thank you.